Today, I'm going to explain exactly how a neural network learns, starting with something you already understand perfectly. Imagine you're a real estate agent. You see three houses: 1,000 square feet sold for 200,000, 1,500 square feet sold for 300k, and 2,000 square feet sold for 400k. Someone asks, "What about 2,500 square feet house?" You instantly say 500k. You spotted the pattern, roughly 200 per square feet, and then applied it. A neural network does the exact same thing, except it doesn't start with the instinct. It stumbles into it. It guesses $1 million, which is wrong, way off. It adjusts it down, guesses 800k, still off, adjusts down again. Guesses 650, closer, keep adjusting until it lands on 500k. That's the entire game. Guess, measure how wrong you are, adjust, repeat. Every AI you have ever used, GPT, Claude, is just this loop running billions of times. Now let's go one level deeper. What is parameter actually? A neuron, which is the same thing as parameter, is a tiny math function. It takes some inputs, multiplies each one by something called a weight, and then adds them all. That's it. Take, multiply, sum. Think of it like a recipe. Your inputs are ingredients: flour, sugar, butter. The weights are the quantities: a lot of flour, very little butter, etc. The weight decides how much each ingredient actually matters in the final result. And this is the single most important idea in the whole video. Weights are the only thing the model can understand. The inputs are fixed. A 1,000 square foot house is always going to be 1,000 square feet. But the model can turn these important dials up or down until the math produces the right answer. GPT's entire intelligence is just billions of these carefully tuned. Here's something most people never learn, and it's genuinely surprising. If you stack layers of these neurons without one extra ingredient, something called an activation function, all those layers mathematically collapses into just one layer. You could stack 1,000 of them and it's secretly no smarter than just one. Why? Because in math, a straight line stacked on another straight line is still a straight line. Picture red dot cluster in the middle of the page and blue dots forming a ring around them. Try separating them with one straight line. Impossible. But let a bend or curve around them. Suddenly trivial. That bend is exactly what an activation function provides. It is one ingredient that lets a network learn complicated and real-world patterns, instead of being secretly flat and shallow no matter how many layers you stack. This single missing piece is a part of what caused the AI winter. Years where researchers stacked layers and got nowhere, because nobody had cracked this yet. So the model makes a guess and it's wrong. How does it know how wrong? That's called the loss, one single number measuring the gap between the prediction and the truth. But here's the real answer. Out of all potentially billions of these little dials, which one caused the mistake and exactly how much should each one change? Think of it like a company where profits drop. The CEO wants to know who's responsible. The CEO asks the deputy asks the manager asks their employee. Blame flows backward, level by level, until you find the exact responsible person. And it's called backpropagation. It flows the error backward through every layer and tells every single weight precisely how much to adjust. This one idea, discovered in 1986, is what finally made deep learning actually learnable. Now imagine all these weights plotted as a landscape, hills and valleys. Where the lowest valley represents the smallest possible error, the model is like a blindfolded hiker standing somewhere on the landscape. If it can't see the whole picture, it can only feel the slope under the feet right now. Propagation tell it which direction is downhill. Then the model takes a step. That stepping process is called gradient descent. How big the step should be? That's called the learning rate. Step too small and you'll crawl forever. Too big and you leap right past the valley and bounce back and forth, never settle. Guess it just right and you walk smoothly down the bottom. Guess, measure the error, walk backward through the blame, step downhill, repeat billions of times. That 4-step loop, scaled up massively, is literally how every modern AI learns, including the one you're using right now. That's day 11.